Hello all, let's start with chapter number 12, electricity. So I would be today covering electric circuit and electric current. So electric circuit is a continuous path of an electric current. It should be a continuous and a closed path. If it is open path, then it won't conduct electric current. Like I have shown you two figures here. In the first one, you can see that the path is continuous and it is closed by a key, or we name it as a switch in this case. So as you can see that it is closed, that means there is some connection between this wire and this wire. If there is connection, then only this bulb will glow. But in the second case, as you can see that my switch is open. If my switch is open, then it cannot conduct electricity. It won't come here. There won't be any electric current here. So there won't be any potential difference here. So it can't conduct electricity if the path is open or discontinuous. Like in this case, if I say the circuit is like this. If it is like this, then it can't conduct again. So therefore, it is necessity that it should be a continuous path and a closed path. If it is not a closed path, then it can't conduct electricity. So this is all about electric circuit. Now we need to come over electric current. So let's move on to the electric current part. So electric current is amount of charge flowing through a particular area in unit time. So how would we define in terms of formula? So it is I equal amount of charge. Charge is denoted by Q. So Q over T. This is the formula for current. Now what does it mean? It means that what amount of charge it can flow through a circuit in particular time or through a particular area. So as you know that Q is the charge has the SI unit as coulombs, or you can write it as C, and times can be written as seconds, that is in S. And current is always measured in ampere. The unit for current is ampere. Now in examination, one very important question is that they ask you to define 1 ampere, like what 1 ampere is. So 1 ampere is nothing but 1 ampere is equal to 1 coulomb in 1 second. So how would you define this is 1 ampere constituted by the flow of 1 coulomb of charge per second. So you can define like this, you just need to remember this part. Then you can define 1 ampere. Now the next thing is conversion. So we have two conversions in this case. You should know about this. So we have 1 milliampere. We need to convert it into ampere. So it will be 10 raised to power minus 3 ampere. And 1 microampere is 10 raised to power minus 6 ampere. So whenever there is a question to convert milliampere into ampere, then you need to multiply it with 10 raised to power minus 3. And if there is a question to convert microampere into ampere, so you need to multiply it with 10 raised to power minus 6. Now, the question is how to measure current. So, there is one device called ammeter. So, it is a device used to measure electric current in a circuit. So, used to measure electric current. Now, the next question is where to connect ammeter into in electric circuit. So we connect like this, we connect it in series. We say a new word, it is a series. So let us see how to connect emitter into an electric circuit. So suppose we have a source, that is battery here, and a key is there or switch is there, and we have an emitter here. So it is connected like this, always in series, never in parallel. If you connect it in parallel, it won't be able to measure your current value. So always it is connected in series, remember this. So that's the end of this video. We'll continue with electric potential in next class.